This is the Math 2 lesson summary video for the lesson entitled Triangle Dilations. In Lesson 2 of Unit 7, Triangle Dilations, the purpose of this lesson is to determine if two geometric figures are similar. A formal definition for dilation that we wrote down in our notes is a transformation of the plane such that if O is the center of the dilation and a non-zero number k is the scale factor, then P' is the image of point P if O, P, and P' are collinear, and the length of OP' divided by OP equals K, the scale factor. Two properties that we want to know about similar figures. Number 1, corresponding angles are always congruent, and number 2, corresponding side lengths will always have the same ratio. In Lesson 2, Triangle Dilations, we are using the rubber band stretchers again, or the GeoGebra software. While I'm going through this video, I will be using the GeoGebra software. In number 1, we are given triangle ABC, and we are asked to use point M located here as the center of dilation. So if you recall from Lesson 1, we use the rubber band stretcher. We would put one point on M, and in this case, we want the side lengths to be 3 times longer than the sides of our original triangle ABC. So what we'll do here is we are going to, here's my rubber band stretcher, but now this is 2 times as long. So to get it 3 times as long, we would need 3 rubber bands. And I've put my fixed point already on M. And what I'm going to do is, in order to get it 3 times as long, I'm going to trace now starting at A. So similar to how we use the rubber band sketcher in Lesson 1, you would put your pencil here and just drag it along the side. So I'm just going to demonstrate how I do one side. So this would be side length AC prime, and it went a little bit further than I would have liked. Let me stop tracing. So my point A should be over here, and my point C should be over here, and then you would keep tracing it. So I'm constantly, what I'm doing is I'm watching this point as I trace it. So what I've actually done is I made nice line segments to help you, and this is what our pre-image and our image should look like: A', C', and B'. And so that is our image doubled. And then we are asked to, starting at as a focal point of N, to sketch triangle ABC half. So when we did that, we did use our rubber band sketcher again, and we found that this would be our image if it was half, a dilation of half the size, scale factor of half. So then we are asked to write some proportions that would relate corresponding sides of these two figures. So we were asked to list some proportions between our pre-image and our image. So a few that I've listed here, AB over A', B' should be equal to BC over B', C'. So if I go back to my image and my pre-image, AB is here, AB over A', B', and that should be equal, my proportion, to BC, which is here, BC over B', C'. And so I've listed some proportions. There are many you can come up with. AC over A', C' should be equal to AB over A', B', so on and so forth. So you can read those. I did do an example from MA over MA'. So there I'm using the focal point. M to A over M to A' should be equal to MB divided by MB'. So we are asked then to complete this statement. After a dilation, corresponding line segments in an image and its pre-image will, and we figured they will always be parallel. And here's why. If I go back to my diagram and I look to see, and let me just take a line segment and overlap it with, let's say, AC. So AC is a pre-image line segment. And if I do the same thing with its corresponding line segment, A prime, C prime, you can see that those two line segments are indeed parallel. I can do the same thing for every single line segment, pre-image and image, and I will always notice that they will be parallel. So then next we are asked to take a look at this triangle ABC and use point A as the center of dilation to locate the vertices of a triangle that has side lengths that are twice as long. So there's several ways we can do this. Some students did take rulers and just doubled the side lengths. And so I actually have created here the image figure that we will end up with. So what's interesting about this figure is we know that we did double it. So we know that we took each side length and multiplied it by 2, which means that each of these points should be midpoints of sides. If they're midpoints, that means that these line segments should be congruent, the ones that I'm marking congruent. We also know that these are parallel. And we do know that these are similar. Well, we do know that there are two angles that will be congruent, those two right there, and then A is shared among the big triangle and the small triangle. So in 6, we are asked to explain how the diagram we created above can be used to prove the following. The segment joining midpoints, which would be BC, of two sides of a triangle is parallel to the third side and half the length. So we can prove mathematically that BC, line segment BC, is parallel to line segment B prime C prime. If you recall from a previous unit, we did talk about corresponding angles, and we do know that because this is a dilation, we do know that angle ABC should be congruent to angle AB prime C prime. So if those are congruent, which is what I've marked, we know that those are corresponding. So the converse of the corresponding angles postulate tells us that if those two angles marked in green are congruent, the lines must be parallel. So therefore, I can indeed prove that those two lines are parallel. If you need more help on the Ready, Set, Go homework for this task, please check the Canvas Student Support site.